Given that x is equal to e to the power sec y, where x is greater than e and y is between 0 and pi over 2, I need to show that dy by dx is 1 over x times the square root of some function of x, where that function is a function of ln x. So that g of x should have ln's inside it. So let's take the x equals e to the sec y, and let's differentiate that with respect to y. So dx by dy. So when I differentiate the exponential, I get the exponential. So e to the power sec y, so that e differentiates to be e. But then by the chain rule, I need to multiply that by the derivative of the inside function. The derivative of sec is sec tan. So sec y tan y. If you look in your formula booklet, you can see that sec x differentiates to be sec x tan x. You get given that result in your formula booklet. So that's all I've used there to differentiate the sec y. I've just made it sec y tan y. Right, so I have differentiated this. Now I have the awkward job where I need to try and make this look like this. Right, well, first things first, I want dy by dx, not the x by dy. So I am going to do the reciprocal of both sides. Dy by dx is going to equal 1 over sec y tan y e to the sec y. Right, so how can I replace the sec y, the tan y, and then the e to the sec y? I want them all to be in terms of x. Well, the e to the sec y here, I know that that's just x. I was told that at the beginning. So I can replace that with an x. Then I'm thinking about the sec y and the tan y. Right, well, if x equals e to the sec y, if I take ln of both sides, then ln x equals sec y. So that is going to allow me to replace this sec y with ln x. Finally, I need to think about the tan y. Well, I know that tan squared x plus 1 is equal to sec squared x. Except in this case, actually, I should be talking in terms of y, not x's. So tan squared y plus 1 is sec squared y. So therefore, tan squared y is going to equal sec squared y minus 1. And therefore, tan y is going to equal the square root of sec squared y minus 1. And we saw previously that sec y is ln x. So that's going to allow me to say that tan y is equal to the square root of ln x squared minus 1. Okay, so I have replaced all of the y terms with x terms. So let me just create a bit more space down here, and let me rewrite this then. So dy by dx is equal to 1 over, I'm going to write the x term at the front there. Then I've got the x, so I've got x ln x multiplied by the square root of ln x squared minus 1. Now I've nearly finished this question. Just have a look at what form I need to write my answer in. Notice that I just want an x at the front. I don't want an x ln x. So I want to move that ln x to be inside the square root, so it is part of this g function. I can do that if I square it. If I want to put something inside a square root, I have to square it first. So I'm going to multiply the inside of that square root by ln x squared. So ln x squared times ln x squared would be ln x to the power 4, and ln x squared times the 1 will be ln x squared. And there we go.